All right, so welcome to the Advanced 3D Printing for Cosplay panel. This costume that you see here is basically your entire motivator for this entire panel because of that bloody staff. That staff was so difficult trying to print using regular techniques. And so I didn't bring this costume here because I didn't want to basically fuss with putting the bloody thing on. All right. So one thing I'm going to introduce kind of my experience. So I've been sewing for about 30 years, and I've been 3D printing for over 10. I've been doing a lot longer than nearly any other cosplayer out there, even celebrity ones. And I've seen I started out with a $2,500 makeup line that has features that now a $100 printer has. So and as a home 3D printing has come a very long way over the years, and that's because patents a lot of Stratasys patents have expired, which enables a lot more advanced features on printers. So everyone knows about PLA, everyone knows about ABS, and more recently PETG. And they're inexpensive, they're relatively easy to print, but they all have some sort of a limitation that makes it annoying to work with a costume, but they make it easy to print. So, and on top of that, over the past 3-4 years, there's been new products like the build plate, spring steel build plates, adhesives, things like nature. There's been like new products that are specifically developed to make using other materials other than PLA, ABS, and PETG possible. Now, I'm going to focus on stuff you can do with a cheap printer. You know, the endo printers. You know, and last time I checked, an endo 3 is like $100, something like that. And basically, what I'm going to emphasize is you don't need to spend a lot of money. You don't need to spend $5,000, $6,000, $7,000, $8,000 to get a printer to print advanced materials and the way you want to. So, all right. So I'm going to also feel free to stop me if you have any questions. So I'm going to list some prereqs for doing some of this stuff. You will need to modify your printers in some way, shape, or form, and most of them are relatively cheap. First things first. If you have a very, very cheap extruder, that is, so the term that you need to search for is all metal extruder. So the very cheap extruders, they actually have the tubing that you feed the filament into go all the way down to what we call the heat break, which is the kind of the little piece of metal that separates the nozzle and the rest of the extruder. The all metal extruders will actually have a piece of metal going all the way up through the extruder itself, the extruder housing itself. The problem is PTFE tubing. It will melt at around 270 degrees Celsius, and if you're trying to, and that works up to ABS, but no higher. So basically, in order to print some of the materials we're talking about here, you will need what we call an all metal extruder. And on top of that, you may also need to upgrade the heater cartridges on the printers as well. A lot of times, the extruder will come with their own heater cartridges, or will have a way of adding a more powerful cartridge on it. So even though you have this all metal extruder, it will still work. If you still want to print with PLA, PETG, and ABS, you can still use that extruder. So I list two companies that just make a lot of this type of extruder. E3D is kind of an old company. They've done this for many years, and their stuff works really well. There's also a company called Slice Engineering. That's the company I use for my specific printer because they were the only company that had an appropriate aftermarket extruder for my printer. But they're both good companies. Now, many printers these days already have some sort of an enclosure. Okay, but if you don't have an enclosure, you can get one on Amazon for relatively inexpensive, or you can make your own through stuff you get at the hardware store. The one thing I will note about enclosures is that if you have an enclosure, make sure it has a fan going in and a fan that's blowing out. The reason is you do not want the inside of the printer to overheat. Because if you overheat the printer, other bad things happen. and these enclosures are also helpful if you're trying to print ABS or ASA because of use a lot. So, right. Okay, so how many of y'all have been 3D printing a very, very long time? Anybody?
What do you consider very, very long?
At least 5-6 years. Okay. In the past, we used some really stupid random combination of stuff to do as bed adhesives. One of my favorites that I did not use was, it was a slurry of acetone, wood glue, and white glue. There's a lot of folks use hairspray, Elmer's glue sticks. Really, really weird crap that is really not designed for what you're trying to do. Now we actually have, in the past few years, we now have dedicated adhesives, and there's generally two of them that I use. The first one is Magic Glue. Yes, that's its name. They actually have like 5-6 different types of different Magic Glues, and they're tailored to one specific plastic. And I think they also sell like a variety pack of like 5 of them for, so you get all the plastic. You get all the ones for like 4 or 5 plastics. The other one is the nanopolymer adhesive. I use this more than Magic Glue because this thing, for a reason, this glue works very well with polycarbonate, which is my current main printing material. I will say this: don't use the brush that they provide with this. I just use like a used toothbrush, so it works better. These adhesives, they cost quite a bit, but a little bit goes a very long way. Like the nanopolymer adhesive, I've been using it for the last 2-3 years, and I still haven't run out. That one bottle. Another thing you will need is a filament dryer box. I've got 2 very expensive boxes right now. They're actually stacked up on a shelf above my printers, but you don't need something super expensive. For the purposes of this panel, you only need a box that goes up to about 80 to 85 degrees Celsius. That temperature is what you need to dry polycarbonate, which is the one polycarbonate, which is the one of the materials that we're talking about today.
Do you have to continually dry it as you're printing, or is it a one-time kind of dry out?
Depends on the material. Most of the 3D printing materials, you can probably get away with about a day or 2 without putting it in the box after you dry it. I will say, if you're doing anything involving water-soluble filaments, which I already talked about, yes, you will have to actually keep it in the box while you print. Otherwise, you will jam your printer. That's how I know. Okay, so let's continue. So, that's it. You can buy boxes like this for $30 to $60 on Amazon. I got two $200 boxes that basically fit lots of filament and does has lots of weird kind features. But as I said, just this doesn't have to be too expensive. Some folks actually use like air fryers and like a food dryer setup to do the boxes. Some people actually have tossed this stuff into an actual oven. So basically, there's many ways to do this. Okay, so I'm going to talk about just your regular, all the materials that you would use to make the stuff. These materials, in some way or fashion, will solve an annoying problem with either ABS, PLA, or PETG. So before I talk about this, I'll need to define a little thing called the glass transition temperature, or TG. So this temperature is basically the temperature which they kind of came up with this kind of like off the seat of their pants. But basically, in kind of layman's terms, this is the point when a solid material becomes not solid, essentially. It basically becomes rubbery. It can be extruded. The thing is, this TG is not like you hit this temperature and all of a sudden it becomes gooey. It's kind of a spectrum. There's kind of a curve, and so. And the TG is defined as, I think it's with some of the standards that define it says that when they get to when they rubberize it to X amount, and so some common temperatures that this happens. PLA is 60 degrees Celsius. This is why you cannot have a PLA printed part in a hot car, because a hot car can easily get up to 140, 150 degrees Fahrenheit, which is around 60 degrees Celsius. Yeah. And remember, this is a spectrum. This is not, you hit 60 degrees, your PLA parts fall apart. It's over a range. So putting in a hot car at 80 degrees will probably also ruin the parts. So this particular property is why PLA does not work in a hot car. PETG is 70 to 80 degrees, but that 10 degrees difference is enough to make PETG parts safe in a hot car. Now, it may not be safe in a hot car in Arizona, but it'll be mostly safe in Texas, though. ABS is 100 to 110 degrees Celsius. That's why you put ABS part in the part, but I don't like printing ABS for various reasons. Okay, so the first material, so I'm going to talk about the first material. So this is polyvinyl butyral, or PVB. This material prints almost exactly like PLA. You will need a slightly hotter build plate, but otherwise it will print just like PLA. You can use mostly PLA settings. This particular material is very good for one thing. You can actually spritz it or nebulize the part with isopropyl alcohol, and it will basically smooth it for you. You do not need SCC 3D. You don't need to use really toxic acetone. You just need isopropyl alcohol. And one of the companies that sells this polymaker actually makes a special nebulizer that costs about $100, but it is well worth the cost. So I'm gonna pass around my little plushie here. This plushie here, the eyes are made out of PVB. One different head, I have to stick it in the head, but pass the plushie, and just feel the eyes there. Yeah. So this material. So if I need to use PLA for something, I use PVB instead, for the most part, because PLA, if you recall, PLA cannot be sanded. You end up melting it. PVB does have the same problem as well, but unlike PLA, I can use just alcohol, and just basically with alcohol solves all my problems. So the main company that basically distributes this film is Polymaker, and they distribute under the name Polysmooth. It'll cost you about $30 a spool, which is a little bit more expensive than PLA, but as I said, it's well worth the not having to literally do stupid wet staining techniques just to sand the material. I just move it into the nebulizer and it works. I will also mention that you don't want to nebulize it too many times because it will collapse eventually. Yeah, the same thing will happen if you dump a ton of acetone on the PLA as well. But acetone is really, really, really toxic, and I prefer IPA over acetone any day of the week. And also remember, all margin loads have 3 beats. I have mentioned. Okay, any questions? Okay, next up is polycarbonate.
Your CDs are made out of?
Yeah, CDs made out of this water bottle. Polycarbonate is extremely strong, even stronger than ABS. ABS is known for being really, really strong, but this is even stronger. And a lot of folks avoid printing polycarbonate because it is fairly difficult, but with the adhesive that has come out, and also with improved and basically with enclosures, you can actually print polycarbonate fairly easy as long as you basically do a few basic things. Yeah, you basically have to slow down, maybe half the speed of PLA prints. You will need a fairly hot bed, and then basically your extruder temperatures will probably be ABS settings plus 40 degrees Celsius, and that will usually get you good decent printed polycarbonate. When you print with polycarbonate, one of the things I hate about ABS is every time I print with ABS, my room smells up. Polycarbonate does not have that problem. It is not infused. And on top of that, polycarbonate, you can use a lot more glues on it. ABS was notorious for requiring it was only adhesible using epoxies. And PET was an even worse example. I think PET has kind of fallen out of favor with some of the armor folks because they found out that you have to use very special adhesives to adhere to it. And if you run out, you'd be waiting several days for more adhesive. Polycarbonate can be adhered with super glue, epoxies, polyurethane glues, basically it works with a lot of different glues. And on top of that, because polycarbonate's the transition temperature is 140 degrees Celsius, it is guaranteed to work in a hot car. Over the last summer, when we had all the really hot temperatures, I actually have a polycarbonate printed part sitting in my car in the middle of the day for 8 hours, and it never distorted. So, if they can survive that, they can survive everything. And the best part about this, it finishes and sands almost like ABS. It maybe finishes even better. So you can very easily sand it, you can paint it, you can do whatever you want with it. Funny enough, you can also smooth polycarbonate with acetone, but I would recommend not doing it. This is so easy to finish that you don't really need it. You don't need the acetone spritz. One thing when I talk about polycarbonate, the discussion about BPAs do come up. So I'm going to go ahead and, because there are valid concerns, because you probably see like all these polycarbonate things say BPA free. BPA stands for bisphenol A, which is a precursor chemical that used to be used to manufacture polycarbonate. Bisphenol A is known to be carcinogenic. However, polycarbonate is inert. Okay. Now there are new, more efficient reactions that are used to make polycarbonate that do not involve bisphenol A and BPA. Now, there are also concerns that BPA could potentially be leached from a polycarbonate product. So I actually did a little bit of digging around, and I basically looked for papers and things like that that are done by entities not supported by the plastics industry, because the plastics industry will say that polycarbonate is safe. It will not leach out BPA. It turns out that BPA will only be leached from polycarbonate under very extended, very grueling environments. In this case, you have to have both of these. You have to have an extremely humid environment. You have to heat polycarbonate to like thousands of degrees. So basically, in my opinion, you do not need to worry about polycarbonate, your polycarbonate parts leaching BPA onto your body. So. For those of you who are having issues, if you try polycarbonate and you realize that you're having a little bit of trouble maintaining the temperatures needed for polycarbonate, a company called 3DX Tech, which I will mention later because they make a lot of really cool 3D printed filament material. I am not sponsored by them, I just like this stuff. They make a polycarbonate blend called Easy Polycarbonate. And that one, when I tested it, it only requires your temperature to be on plus 20 degrees higher than ABS, and that is an easier version of print. The only problem is that one, it's a lot harder there's a lot less of it out there. So so basically it offers out, a lot of times out of stock on the website if you like it. All right, so any questions? Okay, polypropylene. This is also one of these materials that you like to use if, let's say you've got lots of 3D printed armor pieces, and the armor pieces are heavy. Polypropylene is extremely lightweight. It is basically, it is 20% lighter than the next lightest, which is ABS. The main issue is that the polypropylene is actually just slightly harder to print than polycarbonate. So if you figure out how to print polycarbonate, you're very close to polypropylene. Magic Glue actually has a specific formula for this particular plastic. You will probably want to print smaller parts of this, but the parts that are printed out for this are super lightweight, and you can feel it. I would have loved polypropylene when I was in 8-9 years ago when I was printing entire backpack torpedo launchers, and that was heavy. One thing I will mention, ever since I found these materials, I have pretty much stopped printing with PLA, ABS, and TET. These materials are just so much better, and if you figure out how to print them, the parts make me better, they're easier to finish, and you'll have a lot less headache. Because when you're competing in a cosplay contest with a 3D printed part, judges are kind of all over the place on it. Some judges don't want to see one single layer line anywhere. And yeah, and some judges are, they want to see an entirely smooth surface. And in the past with PLA and PETG, since I don't print with ABS anymore, like I was spending hours and hours, and I was suffering mental breakdowns just because I was seeing one little scratch on a part. So this stuff makes things a lot easier to finish and to finish successfully. Okay, so I'm going to talk about support materials. These are fun, by the way. So the thing with support materials is that in order to really effectively use these, you will need some way of having the printer to print multiple filaments. So you can do one of the following. You can have an actual dual extruder printer, which is what I did, or you can modify your existing printer to have dual extruders. I believe for the Enders and the Cruzas, they actually have community mods that actually do dual extruders, and that's usually enough to enable these features. One thing I will also mention, if you want a dual extruder printer, expect to pay at least $500 to $600 for a printer. I believe Flash Forge makes a pretty inexpensive one. But it's basically prepare to pay a little bit more for a printer. But if you have things that just cannot be printed with a single extruder, these things are lifesavers. The other alternative is something called the mixing extruder. So does anyone know? Has everyone seen the new Bamboo Labs printer? Yeah, I'll show you a picture of it in a couple slides. It's kind of the new darling of 3D printing with cosplayers for whatever reason, because they have lots of lots of fanfare, and they have lots of great features for cosplayers, for makes advanced printing pretty simple. But that particular printer is specifically designed to use what we call a mixing extruder. A mixing extruder basically it's a little mechanism behind the point where the extruder loads the filament, and it will basically swap out between different extruders, and then it will actually put that one filament into that one extruder in the printer. That's why it's called mixing. Most people use mixing extruders to do really weird stuff like making multicolored prints. I'm not a fan of that, but the mixing extruder is also possible for using support materials. I will say this caveat: if you're using a mixing extruder, I would only use the Bamboo Labs one for this because it was actually specifically designed for it. Every other printer, you have to basically hack up the printer to be able to use a mixing extruder. So I'm going to show you. So this is my dual extruder printer, and this is me basically printing some stuff using using a support material. So this dual extruder printer this variant is called an IDEX printer or an independent extruding printer. So basically, the y-axis, the x-axis is independently operating on both extruders. This type of printer allows me to print multiple parts at the same time if I wanted to, but I use it mostly to use a lot of support materials. So yeah, so this is a picture of the fiberglass X1. I personally have not bought this printer. I actually don't have a 4-letter printer in my home. But as you can see, it has multiple rolls of filament here, and they basically have some sort of cartridge registration system to basically say, oh, I've loaded polycarbonate, I've loaded PLA, and there's only one extruder, but this entire thing is one big mixing extruder, and so basically it will seamlessly swap between the necessary extruders, the necessary filaments here. People who have used it have raved about the system, and as I have not personally used it, but I would definitely this would definitely be kind of something I would recommend if you want to not get.
So I saw something on a feed that popped up that somebody was printing like a very flat version of Spider-Man and had like 3 to 4 colors on it. Is that the printer they were using?
This will be one. This will be one printer that will be able to do that.
Oh, that's
yes.
neat. Okay.
Yeah, the mixing, some of the mixing extruders, the aftermarket ones, they can do 6, 7 different filaments at once. Bamboo Labs has 4, but I believe also has the feature to swap out filament cartridges as well.
Mm-hmm.
So basically, yeah, it would be done by one of these.
Nice.
Either that, or you would have to basically do some G-code hacking to basically stop the print and relearn different colors, and that gets annoying very fast. Okay, so I'm going to talk about support materials. So okay, before I go on, does everyone know what a support material is? What a support is, basically. Okay, so the first one I'm going to talk about is PVA. So when you use the support material, you try to pair it with a material of similar properties. So I would use PVA in conjunction with PLA or PVB because they have kind of the same temperatures. So this is a water soluble material, and if you use this with a dual extruder system, you will have to basically force the filament to cool down between when you use when the extruder operate, or else it will burn and jam in your extruder. You have to draw it out. When you wash this thing out, it actually takes quite a while to wash this from PVA from, but it'll look a lot like white glue because PVA is also a component of a lot of glues used for paper. So almost white glue will have this. Your wood glue will have this. And if you do not keep this filament dry, you will jam your print. I can guarantee you. I have had that happen before multiple times. I will say, my experience with the PVA, it is very temperamental. Sometimes it does not stick, but usually most of those solutions, most of those are actually fixed with basically just drying up filament and just basically printing slower. Nearly every single 3D printing problem can be solved by printing it slower. Okay, I'm going to talk about a material that you may have not heard of. This is BVOH. This is used a little bit more. This is used a lot more often in Europe. Okay, but and BASF is the only company that actually imports it here in the United States. But this material is really, really cool. Its temperature range is good for PLA and PETG and any similar materials. This is water soluble and it washes out fast. I've often only needed about a couple hours of basically soaking cold water to basically get this developed. This material is actually quite expensive. A 500 gram spool is about $80, $90. But if you can get a hold of this, this thing is a lifesaver. This thing is cool as all heck, and you will absolutely love using this material. You also have to keep it dry. It will jam if you put it in the lab. If you're looking for a place to get this, manufacturers does carry this, and that's why I'm using it. Okay, so this is the USM X1 support filament. You may not have heard this because you probably have not needed this. This one is made by 3DX Tech, which is a great company. I've bought so much from them. I'm not sponsored by them, but I love their stuff. So this film is water soluble, and it can also function as a breakaway film. This is what you use for ABS, polycarbonate, and polypropylene, because its temperatures are close to what they use. You will have to print it a little bit hotter than ABS, but otherwise it will work for ABS just fine. But those of you who have done this for a very long time, you may recall the old way to do ABS support filaments was this really weird HIPS, which basically collapses under, well, after you dip it into a solvent. This using water. And personally, I am not a fan of just having special solvents just to do ABS. But this works for ABS, polycarbonate, polypropylene, and anything in that particular temperature range. It does take a while for it to degrade, and it's really, really, really sticky. But it can't be poured down the drain. But it will. It takes about a day or so to basically just mellow it all out. Okay, this is also very expensive. This is like $90 a roll. But if you have ABS or polycarbonate, use this because this thing is great. One thing I do want to mention. Most of the slicers can generate support structures for you. My personal recommendation is to not use them. If you're using a water soluble filaments, because this is especially true when you have to build them up very, very high. They like to collapse on you. So my recommendation is to create your own structures when you basically model the object. And what I like to do is I just place a few blocks and I subtract the actual object. So I basically do an XOR on it, and basically I'll provide what the exact support I need to basically support whatever I can use. Now, I did mention that a lot of water soluble filament is very, very pricey. If that is a worry, you can set a slicer to only use the water soluble filament on the outside of whatever structure, and use like the regular filament, cheaper filament on the inner filament. So that can save you quite a bit. All right, any questions? Okay. All right, I'm going to talk about carbon fiber. Carbon fiber infused materials, fiberglass infused materials. These things are cool. But you will need one thing before you print. It is likely that your 3D printer has a brass nozzle. Brass nozzles do not work for these materials. These materials will eat those nozzles up. You will need to replace them with a stainless steel or some other. There are even more exotic materials for these nozzles. I think there is a ruby nozzle, which is really pricey. Now, the reason why they use brass is because it conducts heat very, very well, and it's really cheap. So basically, get a stainless steel or a not brass nozzle, and when you do print with these, probably up your temperature by about 10-15 degrees Celsius because these other nozzles do not conduct heat as well. You definitely don't need ruby nozzles. Trust me. If you know how to replace the nozzles, just use stainless steel. All right. So every material that you have heard of, PLA, ABS, PETG, nylon, polycarbonate, there is some companies, there's always some company that have actually infused it with carbon fiber. And this does a lot to the material. First thing, it actually makes the material easier to print because the carbon fiber causes less warping. So if you're having issues with warping and your enclosure is not helping, you may want to try to go to one of these materials because they definitely warp a lot less. The marketing claims that the material has more strength, and that is actually dependent on which direction you're trying to stress it. But so basically, caveat emptor, but they generally do have a little bit more strength than your non-infused material. And on top of that, carbon fiber is also lighter. So if you have a very heavy material like a PLA, this material makes a PLA print a little bit lighter. When you print with carbon fiber reinforced material, don't try to print at 0.1 millimeter heights. Print at least 0.002. 0.2, sorry. Also, if you sand stuff with this, be sure to use an actual respirator. You don't want carbon fiber in your lungs. If you went to the safety panel yesterday, this will be an example of something you don't want in your lungs. Because you don't want carbon fiber in your lungs. That's what I know. All right. So I'm going to talk about, okay, so there's also fiberglass reinforced material. This is a little bit harder to find and because it's not as commonly used, but it is still pretty readily available. And everything we've talked about for carbon fiber filled infused material also applies to fiberglass. When you sand it, please use a respirator because you don't want fiberglass in your lungs. That's what I know. Okay. Basically, whatever temperature settings you use for the corresponding carbon fiber material, use it for the fiberglass material as well. All right, any questions? Okay, so for those of you who use resin printers, I have not forgotten about you. So resin printers, so I've been 3D printing for about over 10 years now, and I didn't get into the resin printer side of things until about 2018 or so. I have to try and remember this. Yeah, 2018, because I kind of remember which costume I first used it on. And at the time, in 2018, the cheapest resin printer I could get was $1,200, and it was crap. It ate up a lot of space. These days, you can get a resin printer for about $200, and it works better than $1,200 piece of product. And resin printer, and resin has I don't have as much experience with resin. However, there are a few advanced things I have tried resin because I have worked longer than most hobbyists. And this is like the speed in which resin technologies have actually come to the household printer space is actually significantly faster than the FDM side of things. So so we'll go ahead and talk about high temperature resins. So these resins are available for use in resin printers. They go up to about 250 degrees Celsius. That's the number I've read. You don't actually need these to have the parts survive a hot car in Texas, really. The regular resins are good for about 150, 160 degrees Celsius easily. So you really don't need the high temperature resins. Now, when people have bad experience with resin prints in a car, it actually is caused by a different issue. But in general, I will say that if you choose to use high temperature resins, my experience with them, if you're doing a resin print, you know you have to basically wash it and cure it. you will have to actually do it twice for a high temperature resin, or else it will not fully clean itself. What has happened was like I only there was one part I only did it once, and it kind of felt a little bit fuzzy, and then I tried to print it and paint wouldn't stay on. So and after I washed it the second time, things went okay. So as I said, just we use these cure and ink wash it twice. The more important thing about resin printing in general, if you want to make a resin print survive a high heat situation, is you must make sure that your parts do not explode under heat. And the reason why they explode under any sort of heat is because your resin printed part has uncured resin inside the volume. When you do resin printing, you often see instructions saying you must drill like a drain hole. You must make a drain hole in your slicer software to basically gradually drain out resin. The reason why they do that is because once you leave the uncured resin in there, if you don't drain it out, all of it, you have to drain out all of it. If you do not drain it out, the minute you subject it to high heat, the resin still cures. Remember, these resins not only cure using high temperature, using UV, but they also cure using heat. So once it gets heated up, it blows up. You either shatters, you have a good mess in your car, and you will probably spend hours trying to fish out resin pieces. So what is more important, as I said, to make sure your print is done in a way that your resin parts do not explode by draining all unused resin. So, first thing, make sure your design you cannot do it in the design phase, you have to do it during the slicer phase. So make sure that during the slicer phase, have holes drilled into the grain. And if you, after printing, you realize there's still trapped resin, before you cure it, you have to drill a hole yourself using a drill and drain out that unused resin. Otherwise, I guarantee you, your resin will explode. And you will not like it. All right. Any questions? All right. Oh, wrong way. So, how many of y'all do actual resin casting? Okay. And you all know about the alcohol ink trick, right? Just to tip. You can do it with 3D printer resin tip as well. It works just as well. This costume happened to be the very first costume I've I actually did with resin printing. And you see all the jewels here on the corset here? That's resin printed. I actually started with a clear and I just poured blue alcohol inks in. All the dangling stuff that's up here, again, alcohol inks.
And that's just with the ink, you can't put like objects or anything like that.
No. You cannot put objects. Do not put objects.
Yeah.
You can use ink. You cannot put objects.
Yeah.
Because if you put objects, you're gonna find that the object will interfere with the build plate coming down towards the back, and what will happen is your object will not adhere to the build plate, and you'll see a nice big blob of resin on the bottom of that. That does not work. As I said, might here, but in my experience, I had almost always had to increase the laser or the light intensity to print something that's tinted. That's not that big of a deal. It's just a very, very slight bump. One thing I will mention is that one thing I will personally mention about this. The parts that come out of the resin printer tends to be dull. And I actually kind of kept it that way because I don't really have any experience with like just polishing with the actual polishing techniques. But I have told that you can actually polish like dull resin into using like various polishing compounds to make it kind of nice and bright. So that is I've been told that is possible. I have not personally tried it since I'm actually not set up to do that. So yeah, that is something that is an option. All right. Any questions? Okay, so conclusion. So one thing this is what I kind of want to get kind of passed down to everyone here, because what I want to say, I have been accused in the community multiple times of basically being the person that basically just pumps money into a problem. And one thing I want to show is that even the absolute cheapest 3D printer, you can actually, if you do appropriate modifications, you can print a lot of additional materials. As I said, I have, ever since I discovered PVB, ever since I discovered polycarbonate, ever I discovered polypropylene, I will not print with ABS, I will not print with PLA, and I will not print with PETG anymore. I do. Those materials are essentially dead to me. And it does not take very much investment. Remember when I said when I was talking about my first 3D printer over 10 years ago, it cost $2,500. Your Ender 3 these days is like $100 and has all the same features. So 3D printing has come down so much that you can effectively, with very little cost, take this risk and essentially upgrade your printing capacity. As I also mentioned, you no longer have to basically come up with your own home-brew concocted adhesives, bed adhesives. You can now have actual properly tested products to actually adhere stuff in the bed. And they work a lot better than all the homegrown stuff we used to do. And that is huge, because this is the key to being able to print these advanced materials. And you'll see the price for all those adhesive things. You may like, I really want to pay $20 for a stick. But as I said, a stick or a bottle lasts a very long time. It'll last you for at least 100 to 200 prints easily. And then I was talking about support materials, and this was my that. Maybe we go back to the beginning. This one freaking staff basically is the motivation for all of the contents of this panel. It basically made me want to buy a dual extruder printer, and for the very first time in my career, I was dreading having to buy one, because I've done so much with just single extruders. But that staff basically told me to go F myself, and essentially said, you have to now buy a dual extruder printer. But it's basically, support materials basically really expand what you can actually print with a printer. You don't have to go through a ton of gymnastics now just to make sure there's a flat surface to print. One thing I would like to also mention, I forgot about polycarbonate. If I had a single extruder printer and I printed with polycarbonate, it is so much easier than either ABS or PETG to basically finish off the polycarbonate part with polycarbonate support structure. They say that those structures come off so easily and finish so nicely that in the past, like, I did not like printing support structures with PLA because they were a bitch to get on. Pardon my language, but they were a bitch. But with polycarbonate, like, I could easily finish it, and it looks like I never had a support structure in the first place. So support materials, especially these advanced materials, really do make your printing a lot easier. You can print a lot more parts, and you don't have to basically undergo the mental gymnastics. And on top of that, with the carbon fiber infused materials, they're great for basically just to make stronger parts and make your printing life probably a bit easier. The carbon fiber infused materials are fairly pricey, but they are worth the cost in my opinion. Because especially when you're doing polycarbonate and polypropylene, because polycarbonate is already fairly difficult to print with, and if you can just slightly reduce the difficulty by using carbon fiber, that always helps. And as I mentioned, your resin prints can be tinted, and obviously prevent your resin prints from exploding, drain all the resin from your part. Okay, I'm about to lose my voice again, but that is okay. Hold on a second. Okay, so we have a little time. I'm going to kind of, as I said, as he mentioned in his panel yesterday, I like to be philosophical in some about cosplay when I do these panels. And as I mentioned, a lot of these, the reason why 3D printers are now 100, the FDM printers are now $100 now, is because of patent, because Stratus's patents just keep expiring year after year after year. Basically, new and better features come about. And I expect the same thing to happen with further developments with resin printers as Formlabs patents kind of fall out of the corner. And it's now to the point where you are printing airplane engine parts with 3D printing. I have actually worked with computer servers with 3D printed parts. 3D printing is not going away, and it's going to get even better. And it's going to come to the point where we may not even need storage anymore. We can 3D print all the stuff. We may be getting, as like in my introductory 3D printing panel, I often talk about 3D printing not being Star Trek replicator technology, but we are getting pretty darn close. And it's going to get to the point where you may be able to 3D print clothing, 3D print any costume you want, and costume will change because of that. So this technology is probably just, in some ways, to me, it's almost as scary as AI in general, but I think it's a good thing. I think it's a good thing, and I think it's good that our 3D printing technology just keep improving year after year after year. And as long as all the patents for all the previous patents keep dropping off, the general consumer like ourselves will reap benefits. And that's just a lot for the U.S. patent system in general. That's just I'm not a copyright person. I'm not a copyright patent person. So, okay, any questions? Any questions about materials I did not talk about? Okay. So one last thing. Any material I did not talk about here is either I can't work with and have discovered usage for cosplay, or they need printers that are $5,000, $10,000, $20,000. So funny thing, 3D Tech, I get a lot of my films from. They make a really fancy printer that will actually print all the really, really advanced materials like PEK, PEI, PTFE, but that printer is like $15,000, and it's huge. And for cosplay purposes, I don't need something that large. I don't need PEK. I don't need PEI. I don't need some of the really fancy materials. And I also did not mention nylon. Nylon, a lot of folks like to. A lot of the 3D printing folks like to print with nylon. Nylon doesn't really work in a cosplay environment. You cannot paint nylon. So you have to make sure it's the right color. You cannot glue nylon, so you have to bolt it. You have to screw it. And on top of that, once nylon starts absorbing water from the environment, nylon loses its strength. So that's why I have not mentioned nylon as a printing material. Everyone likes all the pure 3D printing folks love it, but it doesn't really work for cosplay. And on top of it, its TG is on the same temperature as PLA, so it will not survive that part. All right, any questions? Okay. Well, thanks for coming. I'll probably post these on my cosplay Facebook page and also on the Ushicon Discord. I'll post a link to it. It'll probably be sometime in the next few days. I do have to kind of sneak a little bit of time during the work to do this. Probably based out of the time which I'm looking like I'm actually doing work. So.